In 2018, scientists at the Natural History Museum in London published the results of a DNA analysis that made global headlines. The subject was a 10,000-year-old skeleton found in a cave in Somerset, England. A man who had been lying in the cold dark of Gough's Cave since the Mesolithic period, when Britain was still connected to continental Europe by a land bridge now submerged beneath the North Sea. His name, given by the scientists, was Cheddar Man, and the results of his DNA analysis directly contradicted one of the most deeply held assumptions in British cultural identity. Cheddar Man had dark skin, blue eyes, and dark curly hair. The oldest known inhabitant of what would become England did not look like the English people who would eventually occupy the same island. The pigmentation genetics were unambiguous. The variants associated with light skin that are now near universal in modern British populations were simply not present in his genome. He carried the genetic profile of the ancient Western hunter-gatherers who had spread across Europe from the Middle East after the last Ice Age, a population that was, based on multiple ancient DNA samples now confirmed, significantly darker in complexion than the modern Europeans who descended from them. The reaction to this finding was predictable. Some people were fascinated, some were skeptical, some were viscerally uncomfortable. But the science was solid, and it raised a question that the ancient DNA revolution was uniquely equipped to answer. If the oldest known Briton looked like Cheddar Man, then when did the lighter pigmentation that characterises most modern British people actually arrive on the island? And who brought it? The answer required tracing at least 6 separate waves of genetic transformation over 10,000 years. And almost none of them were what people expected. Cheddar Man himself was found in 1903 in Gough's Cave in the Cheddar Gorge, the same cave system where evidence of Upper Paleolithic Cheddar Man and his people did not simply evolve into the farming communities that followed them. They were replaced. The ancient DNA record for Britain shows one of the most dramatic population turnovers in the entire European genetic archive. Around 6,000 years ago, in the early Neolithic period, a new population arrived on the British Isles from continental Europe. These were farmers, people carrying agricultural knowledge, domesticated animals, and a distinctive genetic profile that traced back to the early farming communities of Anatolia in modern Turkey, which had been spreading westward across Europe for several thousand years. The genetic evidence shows that within a relatively short period, a few centuries at most, these incoming farmers had almost entirely replaced the hunter-gatherer population that had previously occupied Britain. The people who had lived in these islands since the end of the Ice Age, carrying the genetic profile of Cheddar Man and his contemporaries, were reduced to a tiny fraction of the population. Their descendants represent only a few % of modern British ancestry. The Neolithic farmers who replaced them were the people who built Stonehenge. This point deserves to sit for a moment. The monument that is most closely identified with British identity, the structure that appears on tourist merchandise and in national mythology as the emblem of ancient English heritage, was built by people who were genetically closer to modern Sardinians than to modern English people. Ancient DNA extracted from human remains found at and near the Stonehenge site, analysed in studies published from 2019 onward, confirmed this. The builders had ancestry traceable to Anatolian farmers. They were not the ancestors of most people living in Britain today. But even they would not remain the dominant population of the island for long. The Neolithic period in Britain lasted from approximately 4000 BC to around 2500 BC, roughly 1,500 years of agricultural, monument-building civilization before the next great transformation arrived. During that period, these Anatolian-descended farmers constructed not just Stonehenge, but an entire landscape of monumental architecture. Long barrows, causewayed enclosures, cursus monuments, and the avenue connecting Stonehenge to the River Avon. The genetic analysis of remains from Hazelton North, Long Cairn in Gloucestershire, published in Nature in 2021, revealed
detailed family structures among the Neolithic farmers buried there, including evidence of a polygynous social system in which children of different mothers but the same father were buried together. Around 4,500 years ago, something happened to the genetic landscape of Britain that has no parallel in scale anywhere in the European ancient DNA record. A new population arrived. They are known to archaeologists as the Bell Beaker people, named for a distinctive style of pottery that appears in the archaeological record across a wide swath of Western Europe beginning in this period. Their genetic profile was strikingly different from the Neolithic farmers already living in Britain. They carried substantial ancestry from the Yamnaya, the steppe pastoralists of Eastern Europe and Central Asia, who had been expanding westward for centuries, bringing horses, wheels, and a new biological profile that would transform the genetics of virtually the entire European continent. The genetic impact on Britain was extraordinary. Within approximately 200 years of the Bell Beaker population's arrival, roughly 90% of the ancient farmer ancestry in Britain had been replaced by Bell Beaker ancestry. 90% in 2 centuries. The people who had built Stonehenge, the Neolithic farmers whose genetic profile pointed back to Anatolia, were gone. Not just marginalized, almost completely replaced, at a speed and scale that has no clear parallel in the ancient DNA record for any other part of Europe. The most vivid individual from this transformation is known as the Amesbury Archer. His remains were found in 2002 near Stonehenge, and radiocarbon dating placed his death at around 2300 BC, right in the middle of this Bell Beaker arrival period. His grave was one of the richest Bronze Age burials ever found in Britain. Gold ornaments, copper knives, flint tools, and a collection of beaker pottery. Isotope analysis of his teeth revealed that he had not grown up in Britain. He had grown up in the Alpine region, modern Switzerland or southern Germany. He was an immigrant, recently arrived, buried with wealth and status at the very site where the people he had displaced had built their greatest monument. The builders of Stonehenge and the people who replaced them have, between them, almost nothing in common genetically. Britain had been remade. The Bell Beaker transformation in Britain was part of a broader European phenomenon, but nowhere else in Europe shows the same near-total genetic replacement that the British ancient DNA record documents. In some other parts of Europe, Iberia, for example, the Bell Beaker arrival produced significant but less complete genetic change, with the previous Neolithic farmer population contributing substantially to the subsequent gene pool. In Britain, the replacement was extreme. If the Bell Beaker transformation was the largest and fastest genetic change in British prehistory, the Iron Age arrival of Celtic culture was the most misunderstood. For generations, the popular historical account held that Celtic-speaking peoples, the ancestors of the Welsh, the Scots, and the Irish, arrived in Britain as a wave of invasion from continental Europe during the Iron Age, roughly 700 to 300 BC, bringing the Latin artistic tradition, the Hallstatt material culture, and the Druidic religious system with them. the ancient DNA evidence tells a more complicated story. The genetic change in Britain associated with the Iron Age is real, but relatively modest compared to what came before. There was some movement of people, and genetic studies have identified a signal of new continental ancestry arriving in Britain during this period. But it is not the overwhelming population replacement of the Bell Beaker era. The spread of Celtic language and culture across Britain appears to have been driven more by the movement of ideas, trade, and elite culture than by mass migration. What the DNA does confirm is that Celtic genetic ancestry, carried in the descendants of the Bronze Age and Iron Age populations of Western Britain, has been best preserved in Wales, Scotland, Cornwall, and Ireland, precisely the regions where Celtic languages survived the longest. The genetic and linguistic maps of Britain are not identical, but they overlap in ways that confirm a real historical connection between ancestry and cultural survival in the western and northern fringes of them.
Island. Ancient DNA from Iron Age burials has also produced one of the more striking social findings of British prehistoric research: female warriors. Several Iron Age burial sites in Britain have yielded skeletal remains of women interred with weapons and physical evidence of combat training. DNA confirmed the biological sex of individuals whose burial context would previously have been assumed to indicate male warriors. The Iron Age population of Britain included women who fought and communities that honoured them for it. The Druidic tradition, the religious and intellectual class of Iron Age Celtic Britain, described by Julius Caesar and other Roman sources, has left no direct genetic signature, since it was primarily a social rather than a demographic phenomenon. But the physical evidence from Iron Age sacred sites across Britain, combined with the DNA of individuals found in ritual contexts, has confirmed aspects of the Roman descriptions. In 43 AD, the Roman Emperor Claudius launched the conquest of Britain. Within a generation, the Roman military had established control over most of what is now England and Wales, founding cities, building roads, and establishing the administrative infrastructure of a province that would remain under Roman governance for almost 4 centuries. The genetic impact of that 4-century occupation was, by the standards of what the ancient DNA record shows for earlier periods, surprisingly modest. A major ancient DNA study of Roman period burials in Britain, published in the journal Nature Communications, confirmed that Roman occupation brought significant genetic diversity to the island. The city of London, known to the Romans as Londinium, was, at its height, a genuinely cosmopolitan urban centre, with residents whose genetic profiles traced to North Africa, the Middle East, the Balkans, and across the Mediterranean. The Romans moved people. Soldiers, enslaved individuals, merchants, and administrators, drawn from every corner of the empire, were present in British cities. The most striking individual from Roman period Britain is known as the Ivory Bangle Lady. Her remains were found in York, Roman Eboracum, in the 19th century, but it was only in 2010 that ancient DNA and isotope analysis revealed her full story. She was a woman of North African ancestry, likely from a region corresponding to modern Tunisia or Libya. She was buried with ivory bangles, jet jewelry, and glass vessels, the grave goods of a woman of high status. She was not an enslaved person brought to Britain against her will. She was, by all indications, a woman of wealth and standing, living in Roman York as a member of the upper social stratum. But when Roman governance ended, by the early 5th century, the last Roman troops had left and the administrative infrastructure had collapsed, the genetic signature of the Roman presence faded from the broader British population with unusual speed. The Romans built roads and walls and cities that lasted centuries.
Their genes, for the most part, did not. The explanation for this pattern, major cultural impact, modest genetic legacy, likely lies in demographics. The Roman presence in Britain was primarily urban and military. The cities held cosmopolitan populations, but Roman cities were consistently net consumers of population rather than producers. Urban mortality rates in the ancient world were high enough that cities could only maintain their populations through continuous immigration. After Rome withdrew, the population of Britain that remained was a mixture of the old Iron Age Celtic-descended population and the scattered genetic legacy of 4 centuries of Roman occupation. What came next was the third major genetic transformation of British history. Between the 5th and 7th centuries AD, groups from the coastal regions of what is now northern Germany and Denmark, the Angles, Saxons and Jutes, crossed the North Sea and settled in Britain in large numbers. They are collectively known as the Anglo-Saxons, and they gave the English language its name. The language of the Angles became English, which became English. The ancient DNA evidence for the genetic impact of the Anglo-Saxon migration was published in a landmark 2022 study in the journal Nature. The results confirmed that modern English people in the east of England carry approximately 25 to 40% of their ancestry from these continental Germanic immigrants. The proportion is higher in eastern and central England, the regions where Anglo-Saxon settlement was most dense, and lower in the west and north, where Celtic-descended populations were more resistant to displacement. One of the most revealing findings from the Anglo-Saxon DNA study was evidence of social stratification between the incoming migrants and the existing British population. At several sites, the ancient DNA of individuals buried with Anglo-Saxon material culture and the ancient DNA of individuals buried with older British traditions showed clear genetic differences, suggesting that the two groups were not, in the early period of migration, freely intermarrying. The Anglo-Saxons and the British Celts lived in proximity but maintained genetic separation for at least several generations. The 2022 Nature study on Anglo-Saxon Britain analysed ancient DNA from over 460 individuals from more than 80 burial sites across England, making it one of the largest ancient DNA studies of any historical period anywhere in the world. The scale of the dataset allowed researchers to trace specific genetic patterns at the level of individual communities, showing that in some villages, Anglo-Saxon and British individuals lived literally side by side, but did not intermarry for several generations, while in others, the genetic mixing began almost immediately. The variation suggests that local social conditions, rather than any empire-wide policy, determined the pace of integration. The Vikings arrived in Britain in 793 AD, when Norse raiders attacked the monastery at Lindisfarne off the Northumbrian coast. The event is traditionally treated as the opening of the Viking Age in Britain, and the shock it caused in contemporary Christian Europe is well documented in the written sources. But the Viking relationship with Britain was not simply one of raiding and departure. It was also, over the following 2 centuries, one of settlement, political control, and genetic contribution. The region known as the Danelaw, the area of northern and eastern England that came under Norse political control following the major Danish invasions of the 9th century, represents the densest zone of Scandinavian genetic influence in the modern English population. Ancient DNA studies and the genetic analysis of modern British populations conducted as part of the People of the British Isles project both confirm elevated Scandinavian ancestry in the populations of Yorkshire, Lincolnshire, and the northeast of England, consistent with the historical geography of Scandinavian settlement. The Vikings who settled in Britain were not genetically pure Scandinavians by the time they arrived. Ancient DNA analysis of Viking Age burials across Britain has revealed individuals of mixed ancestry. People with genetic profiles combining Scandinavian components with British, Irish, and even Eastern European and Near Eastern ancestry, reflecting the extraordinary mobility of Viking networks that stretched from Greenland to Constantinople. One of the most remarkable individual cases from Viking Age Britain comes from a mass burial site near Oxford, dated to around 1000 AD, where the skeletal remains of approximately 40 young men were found with clear evidence of violent trauma. DNA analysis confirmed the individuals were predominantly of Scandinavian ancestry. Historical records mention a massacre of Danish settlers ordered by King Ethelred II of England on November 13, 1002, an event known as the St. Brice's Day Massacre. The Oxford remains are likely the physical evidence of that documented historical event, connecting ancient DNA to a specific date in written history. The people of the British Isles project, based at the University of Oxford and completed over a decade of research, analysed the DNA of over 2,000 modern British people with 4 grandparents all born in the same rural area, a methodology designed to capture deep regional genetic patterns before the homogenizing effects of modern mobility. The Norman conquest of 1066 is the last successful military invasion of England, and in popular historical consciousness, it is often treated as the event that definitively shaped the English nation. William the Conqueror's victory at the Battle of Hastings on October 14th of that year replaced the Anglo-Saxon ruling class with a Franco-Norman aristocracy and triggered cultural and linguistic changes that permanently altered English society. The genetic impact, however, tells a more nuanced story. The Normans were, genetically, primarily descendants of the Frankish and Gallo-Roman populations of northern France, with a component of Scandinavian ancestry reflecting their own Viking heritage. Norman derives from Northmen, the Norse settlers who had established themselves in what is now Normandy in the 10th century. But their conquest of England was, in demographic terms, relatively small in scale. The Norman aristocracy that replaced the Anglo-Saxon nobility numbered in the thousands, not the hundreds of thousands. Their genetic impact on the broader English population was correspondingly modest. What was not modest was their cultural and linguistic impact. The Norman ruling class brought French as the language of power, law, and prestige. For several centuries after 1066, English was the language of the peasantry, and French was the language of the court. The compromise that eventually emerged, Middle English, absorbing enormous quantities of French vocabulary into a Germanic grammatical framework, was the direct product of this social arrangement. The most extraordinary individual-level application of ancient DNA to Norman period Britain is the case of Richard III. His remains were discovered in 2012 beneath a Leicester car park, the site of the medieval Greyfriars Church where he had been buried after his death at the Battle of Bosworth in 1485. DNA extracted from the remains was matched to living descendants of his sister, confirming the identity beyond doubt. The Richard III DNA analysis also revealed a discontinuity in the male line ancestry of the royal house, raising questions about the biological lineage of certain English kings, questions that, once raised by the genetic data, could not be unasked. The Norman period also brought the most comprehensive transformation of the English landscape since the Roman occupation. The Domesday Book, the systematic survey of English landholding commissioned by William in 1086, was itself a product of the administrative culture the Normans imported from France. The ancient DNA revolution in British history has produced not just a clearer picture of who the British people are and where they came from. It has also opened a window into how they lived, what they ate, what diseases they carried, and how those biological experiences shaped the genome that modern British people carry today. Dietary reconstruction from isotope analysis of skeletal remains tracks the transformation of British diet across the major genetic shifts. The Mesolithic hunter-gatherers like Cheddar Man ate primarily meat and freshwater fish. The Neolithic farmers who replaced them shifted to a diet dominated by cereals and dairy. The Bronze Age Bell Beaker people brought significant pastoral components. Their cattle-heavy economy is reflected in the bone chemistry of their remains. The Roman period introduced a more varied Mediterranean-influenced diet to urban populations, including significant quantities of marine fish. Anglo-Saxon and Viking communities showed high reliance on cereals, with animal protein from domesticated livestock. The Black Death of 1348 to 1349 killed between 30 and 50% of the English population within approximately 2 years. Ancient DNA from mass burial sites associated with the Black Death in London, including the East Smithfield Emergency Cemetery, has been used to confirm the presence of Yersinia pestis in plague victims. But the genetic legacy of the Black Death extends beyond identifying the pathogen. The catastrophic mortality created strong selection pressure on immune-related genetic variants. Modern British people carry elevated frequencies of specific immune gene variants, including those in the ERAP2 gene discussed in other ancient DNA research, that appear to have been selected for by the plague and that remain in the population today as a biological memory of the epidemic. Work patterns detectable in skeletal remains document the physical demands placed on ordinary people across different periods. The bones of Neolithic farmers show specific stress patterns from grinding grain. Bronze Age individuals show the skeletal signature of extensive horse riding. Medieval remains from working-class burials in English cities document severe physical stress in individuals who were still children when their heaviest labor began. The ancient DNA record has also illuminated the long history of migration into Britain that predates the modern era. Let's bring the entire picture together, because the genetic history of Britain is, in microcosm, the genetic history of humanity itself, a story of waves, replacements, mixtures, and unexpected inheritances layered over 10,000 years. The oldest known inhabitant of Britain, Cheddar Man, had dark skin and blue eyes. His genetic line was almost entirely replaced by Anatolian farmers who arrived 6,000 years ago. Those farmers built Stonehenge and left traces of their ancestry in modern Sardinians. They were then replaced, 90% of their DNA wiped out in approximately 200 years, by Bell Beaker people from the Eurasian steppe, who became the dominant genetic population of Bronze Age Britain. The Iron Age added Celtic culture, which spread through Britain more as a cultural wave than a genetic one, but which preserved its genetic signal in Wales, Scotland, and Ireland most strongly. The Romans brought 4 centuries of cosmopolitan genetic diversity, including individuals of North African ancestry buried as aristocrats in York, but their genetic legacy faded when the administrative structure that had supported them collapsed. The Anglo-Saxons brought 25 to 40% of the ancestry now present in Eastern English populations, transforming the language and the genome simultaneously. The Vikings settled the Danelaw and left a Scandinavian signal in the DNA of northern England. The Normans changed the culture and the ruling class, but left a lighter genetic footprint than their political dominance would suggest. The result, the modern British person, is a genetic archive containing all of these layers simultaneously. Every major movement of people through or onto the British Isles over the past 10 millennia contributed something. The hunter-gatherers, the farmers, the steppe warriors, the Romans, the Anglo-Saxons, the Vikings, the Normans. Each left a trace, and the modern genome carries them all. The 2022 Ancient DNA Study of Anglo-Saxon Britain, the 2019 Stonehenge Genomics Study, the Cheddar Man analysis of 2018, the Roman London Diversity Research, taken together, these studies constitute a complete rewriting of British prehistory from the genetic record up. The story they tell is more complex, more interesting, and more human than the national myth it replaces. There is no pure British bloodline. There never was. And the DNA makes that not a political statement, but a scientific fact, confirmed in bone after bone, from cave to burial mound to Roman cemetery to medieval churchyard, across 10,000 years of the most studied set of islands on Earth.